Hey everybody, we are going to do this quiz review as quickly as possible. I'm going to go through all 14 or 15 questions from the review, and if you can do each one of these questions, you should be absolutely fine for the next quiz. All right, first question that I have given out says find the rates of the rates of change for this table and use it to determine whether this is a linear or non-linear equation. Okay, so what I'm going to do is I'm first going to find my rates of change, or sorry, my x change and my y change. Okay, so what I'm going to do, I'm going to say, what does it do? What does it take for me to get from -9 to -5? Well, I added 4. If you didn't understand that, then you need to look at a number line to see how that works. Okay, from -5 to 3, I added 2. From -3 to 1, I added 4. And from 1 to 17, I added 16. Okay, for the next one, -3 to -1, I added 2. From -1 to 0, I add 1. From 0 to 2, I add 2. And from 2 to 10, I add 8. Now what I am going to do, I'm going to extend the page, give myself a little more room. And to find my rates of change, what I need to do is find 4 different fractions. First of all, this guy divided by this guy. Okay? So it's really this right here. I'm going to divide the 4 by the 2. And then I'm going to move it. I'm going to divide the 2 by the 1. And then I'm going to divide the 4 by the 2. And then I'm going to divide 16 by 8. It's always the change in the y divided by the change in the x. So for the first one, it's 4 over 2 equals 2. For the next rate of change, it is 2 divided by 1 equals 2. For the following one, it is 4 divided by 2 equals 2. And the final one, 16 divided by 8, what do you know? That also equals 2. So if I see that all 4 of these have the same rate of change, I can conclude this. Linear, because there is a constant rate of change. Okay, that's how you do that problem. Okay, that's what the rate of change is. We went over several examples in class. Now I'm going to pause the video and I'm going to align the board. I'll be right back. And I'm back. All right, so we are now going on to question 1 from the textbook. It asks us to graph these linear equations and tell whether each of them is linear or not. Well, we don't know if they're linear yet or not. Of course, I told you a trick that you could figure it out. But let's say we didn't know it. What I'm going to do is I'm going to do a table of values. X, Y, and I'm going to do -2, -1, 0, 1, and 2. And what I need to do is figure out what Y is for each of these. Well, Y is 2 minus 4 times whatever X is. For my first one, it's -2. Well, I've got this -4, -2. When I multiply those together, a negative times a negative gives me a positive 8. And what I am left with is y equals 2 plus 8. That's going to give me 10. That's it. Next one. Move this over a little bit. I will be erasing it soon, but I'll leave it there for a moment. The next one, y, again, equals 2 minus 4 times x, but x is now -1. And -4 times -1 is +4, so I have 2 plus 4. Y equals 2 plus 4, so y equals 6. And I put that right here. The next one, I have y equals 2 minus 4 times x. Now x is 0, so I'm going to do 4 times 0. All of this is just 0, and so all I have is y equals 2. That one was easy. I do my next one. Y equals 2 minus 4 times x. X is now 1. And so I get y equals 2 minus 4 times 1 is 4, so 2 minus 4. 2 minus 4 is negative 2. So y equals negative 2. And then I'm going to erase my red one again here, because I am out of room. And I'm going to do the final example. I get that y equals 2 minus 4 times x. X is now 2. So I have y equals 2 minus 4 times 2 is 8. So 2 minus 8. 2 minus 8 is negative 6. And so that's what I have there. Okay? Once I have all of these, I can erase all of my work, which I'm going to do right now. Got most of it. Okay? And what I'm going to do is I'm going to add a graph. So I need to go into the gallery. It'll take me just a second. That's the one I want. Okay. And I have a graph here. I'm going to move this right down here. Now what I'm going to do is I'm going to graph each of these 5 points. What 5 points am I talking about? Well, here's one. Here's my first point, negative 2, 10. My second point is negative 1, 6. 0, 2. 1, negative 2. And 2, negative 6. I'm going to graph all 6 of those points. Or all 5 of those points, rather. So the first one, negative 2, negative 2, 10. I go left 2. Okay. I'm going to go left 2, up 10. There's my first point. The next one, negative 1, 6. Left 1, up 6. 1, 2, 3, 4, 5, 6 is going to be right here. Okay. The next point, 0, comma 2. We're going right there. 1, negative 2. I go over 1, down 2. And finally, 2, negative 6. I go over 2, down 6. 1, 2, 3, 4, 5, 6. That's going to be right here. And then I'm going to just create a straight line through them, or as straight as I can do by hand. And this is going to be, well, you know what, I'll actually do it with a real line so that we can see if this is linear or not. And I will do this. Let's see, it goes through that point. Go through this point there. Looks like it goes through just about every point I want it to. So I'm going to conclude that this is linear. Okay? It's linear because I can draw a straight line to graph it. That's how I do that. Okay? So that one was number 1. We're going to now do number 2. I'm going to take, at some point I will clone my graph. But first of all, let's talk about number 2. I cannot do the table of values on this because this is a special case. There are 2 special cases of linear equations. X equals some number and y equals some number. These are 2 different kinds that are special. And what we have to do for these cases is actually quite easy. All we have to do is think of points where x is 2, because that's my only rule. X has to be 2. So one point is 2, comma 0. See, x is 2, y is 0. It doesn't matter what y is as long as x is 2. I'm going to pick another one. 2, comma negative 1. 2, comma 8. 2, comma, let's say, negative 7. All right? There's a bunch of points where x is 2. And now all I'm going to do is I'm going to graph it. And I'm going to use the same graph that I just used here. I'm just going to recycle it. I don't need this line on there quite like that. I'm going to graph all 4 of those points and see what's happening. First of all, 2, comma 0. I go over 2, up none. That's right there. For 2 comma negative 1, I go over 2, down 1. That's right there. 2, 8, I go over 2, up 8. That's going to be right there. And over 2, down 7 is going to bring me right here. I think it's pretty obvious what's happening there. We have a straight line that is vertical, and I will just graph it like that. Do not forget when you're graphing it to put your arrowheads on, because it does go on forever. And I have graphed this, and it's very obvious. This is a straight line, so this is a linear equation. So far, linear, linear. This one was linear. This one was linear. Now let's find the next one. There's no real trick here, so I do need to do a table of values. And so what I will do is I will set up the table that we always do. X, Y. I'm going to pick -2, -1, 0, 1, and 2. And I'm just going to put up here, so we remember it, my order of operations. Exponents goes before multiplication. That's what I want you to keep in mind. So when we plug these in, y is going to equal 3 times x, which is now -2, squared. I do this first. That has to be done first because exponents come before multiplication. Okay, look at this over here. Exponents come before multiplication. So I'm going to say -2 times -2 is going to give me 4. And so I just do 3 times 4, y equals 12. Okay, let's try it again. Y is going to equal 3 times, this time -1 squared. Once again, I will do -1 squared first. -1 times -1 is +1. So I get y equals 3 times 1, so y equals 3. The next one's super easy. Y equals 3 times 0 squared. 0 times 0 is 0, so I get y equals 3 times 0, which is y equals 0. And I'm most of the way done here. I know a trick at this point that will help me do it quicker, but I'm not going to use it because you don't know it yet. So we'll just do it like this. And we get y equals 3 times now 1 squared. 1 squared is 1, so y equals 3 times 1. Y equals 3. And finally, y equals 3 times 2 squared. So y equals 3 times 4. So y equals 12. My trick would have been, notice, this is like a line of reflection. This y value, the y value here is 0. This y value here is going to be the same as this y value here, 3 and 3. And then this y value here, 12, is going to be the same as this y value over here. Okay? Nevertheless, we have 5 points, and we're going to plot them now. I'm going to use my same graph that I've been using. I'm going to move my line. Might not even need it again. Let's find out. -2, 12 is going to be over 2 up 12. It's going to be right about here. -1, 3 is going to be over 1 up 3. Right about there. 0, 0. Everybody knows where that is. 1, 3 over 1 up 3. Over 2 up 12. And this is clearly not linear. Here's the graph I have. More or less. So this is clearly not linear because it does not make a straight line. And that on a test, what you might say is not linear because the graph is not a straight line. And that would be enough information for me. Okay, we are moving on. At Maggie's Music, the equation U, that stands, by the way, for used, is equal to 3/4 N. That's going to stand for new, plus 1. And that represents the price for a used CD when the original selling price N, or when the original selling price was N for a new CD. How much will a used CD cost for each of the listed new prices? Okay, so we've got this equation, U equals 3/4 N plus 1. So this music store takes the new price of a CD, puts it in here, multiplies by 3/4, and then adds $1, and that gives them the used price. Okay, and then it wants us to graph and tell whether this is linear. So first step is very straightforward. We're just making a table of values. U equals 3/4 times N, which is 8, plus 1. Well, hey, these cross cancel. 8 and 4 have a common factor of 4, so I divide it out. 4 becomes a 1, 8 becomes a 2. I have U equals 3 times 2 plus 1. So U equals 6 plus 1, or 7. So for an original new price of $8, I sell it used for $7. That doesn't sound like a great deal. I bet they don't do a lot of business at Maggie's Music Store. That's not what I meant to do. Okay. Next one. For $12, U equals 3/4 N plus 1. So U equals 3/4 times 12 plus 1. I've got cross-canceling going on again here. 4 is 1, 12 is 3. I get U equals 3 times 3, which is 9, plus 1. So $10. Still not a great deal. I'm not shopping here. There's no way. $10 for a used CD? I just bought 2 used CDs. I know, who uses CDs anymore? But I just bought 2 used CDs on Amazon, paid $8 for both of them. So I think that's a ripoff. Anyway, we're still doing the problem. For the next one, $14, U equals 3/4 times 14 plus 1. Okay? I do still have some cross-canceling, but 14 is not a multiple of 4, but they both have a factor of 2. So if I divide both by 2, I get 2 for 4 and 7 for 14. And so what I have, U equals 3 times 7 divided by 2 plus 1. Let's figure out what that is. 3 times 7 is 21. So 21 over 2 plus 1. 21 divided by 2, that's $10.50, because $20 divided by 2 is $10. So this is this is $10.50 plus 1, so I get $11.50. So that's the cost of my UCD when I paid $14. And finally, for $20, U equals 3/4 times 20 plus 1. So U equals, well, I've got some cross-canceling here again. I like that. 4 becomes a 1, 20 becomes a 5. So I've got U equals 3 times 5, that's 15, plus 1. So U equals $16. I'm going to move all this down. And I'm going to say, hey, this is $16 here. And that's all there is to it. I'm then going to graph it and see if this is linear. Okay? So I'm going to go back here, see if, yep, my graph is still up. So I'm just going to bring that there. Okay, and what I need to do is I need to label these. Well, what was I solving for? I was solving for U, so U is going to be my y-axis. And N is going to be my x-axis. And then I'm just going to figure out what I need to do to make this fit. I think probably doing 2, or I'm sorry, not that. 2, 4, 6, 8, 10, 12, 14, 16, 18, and 20. That should be fine. And then for used, I can do the same thing. 2, 4, 6, 8, 10, 12, 14, 16, 18. So I'm just counting by 2s instead of by 1s. And then I'm just going to graph these. My ordered pairs, 8, comma 7. So I go over 8, up 7. That's going to be over 8, up 7 is going to be right here. 12, 10, over 12, up 10. That's going to be right here. The next one is 14, 11, 50. So over 14, up 11, 50. It's going to be right about here. Okay, and then finally, they can come in. Up over 20, up 16. I didn't tell them, but over 20, up 16 is going to be right here. Draw a straight line-ish. And I can say that this is a linear equation because I get a straight line.
No, Edward.
Okay.
Are you serious? Edward. You stepped on me.
Well, not my fault.
And we're back. Okay, now we are going on to the next topic here, slope of a line. Slope of a line, real easy. We just use our slope formula and plug in numbers. M equals y2 minus y1 over x2 minus x1. The mistakes that students often make are putting x's on top instead of on the bottom, or putting x and y on top and x and y on bottom. This is the formula, you just have to learn it. Then we need to pick one of these points to be point 1 and one of these points to be point 2. Just for the sake of being easy, I'm going to make the first point point 1. So x1, y1, x2, y2, and then I'm just going to plug in my numbers. y2 is 4, minus y1 is 3, x2 is 2, x1 is 6, so 2 minus 6, and I just figure out what this is. 4 minus 3 is 1, 2 minus 6 is negative 4, and so my slope is negative 1/4. I leave it as a fraction because I cannot simplify that anymore. That was easy, right? Great. Number 6. 1, comma 4 and negative 1, negative 3. Once again, we start with our same formula. I'm sorry. It's not y equals. That's silly. M equals y2 minus y1 over x2 minus x1. Okay? And then I'm going to label my points again. x1, y1, x2, y2. And we plug in. y2 is negative 3. y1 is 4. x2 is negative 1. x1 is 1. And do not forget the minus signs that were there before. And I have negative 3 minus 4. Well, that's negative 7. Negative 1 minus 1. That's negative 2. But I can simplify this. Even though 7 and 2 have no common factors, a negative divided by a negative is a positive. So I have 7 over 2 positive, because it's just easier to write nothing than to write 2 negative signs. Okay? So that is my slope there. I'm going to move some of this. That was weird. Okay. Sorry, everybody. My computer is awfully slow when I use my small one. Okay? So I'm going to take this. I'm going to move it over. 7 over 2 is still my answer, though, even though I've moved the answer. Okay, and I do my next one. Once again, m is equal to y2 minus y1. Are we seeing a trend here? Over x2 minus x1. I'll call this one x1, y1, x2, y2, and then I just plug in. M equals 0 minus negative 3. Notice there was a negative sign on this y, so it stays here, negative 3, and there's still a minus over here from my formula, so that has to be there as well. So I have 2 negative signs, and anytime you see 2 negative signs that are right next to each other, you should say, hey, chances are that's going to be the same as adding, so I'll just add instead. And then x2 minus x1, that's negative 4. Take away 0. I love taking away 0. It's so easy.
Yes.
And then I have 0 plus 3 is 3. Negative 4 take away nothing is still negative 4. And so I will just say, hey, my slope is negative 3/4. And I'm done. Yay. This topic's pretty easy. Now I have the same question, but instead of giving me points, they give me a graph. So I could do two things. I could, no matter what I'm going to do, the first thing I need to do is find 2 points on my graph that actually are like real numbers there, like whole numbers. What I mean by that is right here, that is like 1, 2.7. That doesn't help a lot. That's hard to tell what it is. What I want is 2 points that are at intersections of my grid lines. So right here I have picked 2 points. This is 0, 2 and 3, 4. Okay? I have 2 points. So now I can do one of two things. I can either use the formula I was just using in the previous section, or I can do something even easier. I can look at my graph and say, I know my slope is equal to my rise over my run. So what was the rise between these 2 points? Well, I went up 2. So my rise is going to be 2. And then what's my run? Well, I went over 3. So my run is 3, and my slope is 2/3. And I find that easier than using the formula. If they give you the graph, it's easier just to think about rise over run. Okay, number 9, same thing. I gotta find 2 points that are on grid lines. So there's one. Where's my other? Looks like right here. And I'm gonna label those 2 points just so I know. 2, -1. And this one was -2, 2. All right. And I'm going to think about it once again. What's my rise? What's my run? Because that's my slope. Rise is, I'm actually going down, so my rise is going to be negative. 1, 2, 3. I went down 3, so my rise is -3. And then my run, how far over? Run, if you're going to the right, and we're always talking about going to the right, that's always going to be positive. So I have 1, 2, 3, 4. I went over 4. My slope is -3/4. Excellent. Finally, number 10. We are moving right along here. I need 2 points. Uh-oh. This is one of my special cases. Anytime you have something like that or something like that, you have a special case. With the special case where we're the one that we actually have here, this one, I'm going just straight across. You can think about it. How steep is a line that is going straight across? Well, there is no steepness. It's just going straight. So my slope, there's no rise. So the rise is 0 no matter what the run is. Okay, so 0 over x. My slope is going to be nothing because I'm going horizontal. Anytime you have a horizontal line, you don't really need to do any work. You just know that your slope is 0. By the way, if you had this line here, your slope is going to be undefined because you'd actually end up you'd end up trying to divide by 0, and we should remember that we cannot divide by 0. Okay? But you have a horizontal line, the slope must be 0. Okay, a camp charges families $6.25 per month for one child, and then $2.25 per month for each additional child. The linear equation y equals 225x plus 625 represents the amount a family with x additional children would pay. Identify the slope and the y-intercept and use them to graph the equation. Well, remember your slope and your y-intercept. When you have y equals mx plus b form, your slope and your y-intercept are already given to you. M is the number in front of the x is going to be your slope, and the number here is going to be your y-intercept. Okay, they give that to us. We have y equals 225x plus 625. Now the only tough part about this, I'm going to pull in a graph. The only tough part about this is picking my my units so that the data actually fits on here. I can't count by ones because look at my y-intercept. It's 625. So what I'm going to do is I'm going to count by, I think I'm going to count by 100. So this one here would be 200, 400, 600, 800, 1,000. And this one here would, and x is going to be number of children, or number of additional children. So what should I count by here? Well, I don't want to count by a lot because how many additional children are you going to have? Probably not in the hundreds. Let's just count by ones. This is going to be one additional child, 2, 3, 4, 5, etc. Now I'm going to graph this. 225x plus 625. Remember, it asked me to find my slope and my y-intercept and use that to graph. Well, here's what that means. This is my slope here. Let me use some color. This is my slope, 225. And this is my y-intercept, 625. Well, I just go to my y-intercept, and that's where it crosses the y-axis. Well, y-axis is here. Okay, so I go up 625, up to 6, up to 625, right about there. And then from there, I use my slope. My slope is saying every time I go up by 1 on x, I go up 225 on y. Okay? So rise is 225 over run. My slope is 225. Remember, slope equals rise over run. So if I write 225 as a fraction, it's 225 over 1. So my rise is 225 if my run is 1. So I go I go over 1 and up 225. That would be right here. I've gone up to 850. That doesn't actually look like 850. I'm going to erase that. 850 looks like it's right over here. And then I can do it again, too. I can go over 1 more and up another 225. That would be 1025. I actually go off the grid. This is my equation. However, if you really think about it, none of this stuff makes sense because you can't have negative children, okay, or negative additional children. So what we're going to say is, starting here, our graph goes up, but before that point, it doesn't exist. Okay, that's our graph there, and we're going to move on. It says to write the equation of the line that passes through each pair of points in slope-intercept form. -4, -4, 3, and -2, 1 is our first pair of points. And remember, to do this, we're looking to find y equals some number x plus some number. And remember, those are going to be m and b. And so we actually need to find m and b here. Finding m is easy. We did that a couple slides ago. M equals y2 minus y1 over x2 minus x1. I'll call that x1, y1, x2, y2. Okay? And so I get m is equal to 1 minus 3 over -2 minus -4. Well, once again, I have a negative next to a negative, so I know that's going to be a positive, or a plus, rather. 1 minus 3 is -2. -2 plus 4 is going to be +2. And so my slope is -2 divided by 2. 2 over 2 is 1. And the negative divided by a positive is still a negative. So my slope is -1. But I'm not done. I still need to find b. And here's the way I find b, once again. I take my equation. Y equals m, but now m is -1. I know that. X plus b. And I'm going to temporarily replace x and y with, actually let me change that, x and y with an x and a y from one of my points above. I picked the point that looks the easiest, and I guess this second point looks easier. -2 and 1. That's my x and my y. And so what I will do is I'll just replace them. 1 equals negative 1 times whatever x is negative 2, plus b. And remember, I don't know what b is yet. That's what I'm trying to find. But now I have enough information to find it. Because negative 1 times negative 2 is positive 2 plus b. If I have 1 is equal to positive 2 plus b, well, I just think about it. Minus 2 on both sides. B is equal to negative 1. Okay? And so now that I have what b is and I have what m is, I am just about done. All I have to do is put this back into my equation, y equals mx plus b, and just replace m and b. M I knew from above was negative 1, so y equals negative 1x. And b I just found was negative 1, so negative 1x minus 1. I can even write this a little bit simpler. I could just say negative x minus 1. And so I think I'll just erase that. But either way is correct. This is not wrong, but this is an easier way to write it. Just y equals negative x minus 1. Okay, and then we're just going to do the same thing 2 more times. For 2, 7 and 5, 2, m equals y2 minus y1 over x2 minus x1. So m equals 2 minus 7 divided by 5 minus 2. And the reason I got that, I said this is x1, y1, x2, y2. Okay, so 2 minus 7, 5 minus 2. So m is equal to, this is 2 minus 7 is negative 5. 5 minus 2 is 3. And I have that, my slope is going to be negative 5 over 3. Now I'm going to pick my easier point. They both look relatively easy, so I'll just, I'll pick the one with the smaller numbers, 5, comma 2. I'm going to write it down here so I can go down. Okay, I have my slope. I plug it into my equation, y equals mx plus b, negative 5 over 3 times x plus b. And I'm going to replace 5 and 2 for x and y. So 2 equals negative 5 over 3 times 5 plus b. I'm going to do this. There's no simplification I can do here. So 2 is equal to negative 25 over 3 plus b. And then I just add 25 thirds to both sides. 2 written as thirds is 6 thirds, plus 25 thirds is equal to b. And so I get 6 plus 25 is 31 thirds equals b. Okay, so now that we have b, we are actually done with our equation. So all we need to do is put our slope and our b back in place. Y equals mx plus b. So we look up here, my slope was negative 5 thirds. So y equals negative 5 thirds, x, and then plus b, which is 31 thirds. We're going to leave this all as fractions because it doesn't simplify and it's easier to work with that way. And so we're done at that point. Okay? So, final question for the review is going to be right here. And let's see if I can just move all of this. Come on. See if I can move all of this over so I can give myself some more room. There we go. And so the first thing I want to do, again, find m. M equals y2 minus y1 over x2 minus x1. I'm going to pick this one to be x1, y1, x2, y2, and then I'll just plug them in. Same thing we've been doing like 6 times already in this video. So negative 5 minus 2 over 2 minus 4. Negative 5 take away 2. Use a number line if you have to. It is negative 7. 2 minus 4 is negative 2. And so we have our slope m equals 7 over 2. And we're done. We cannot simplify this anymore. The reason it is 7 over 2 and not these negatives, because remember, a negative divided by a negative is a positive, so this just becomes a positive 7 over 2. Now I'm going to take my easier looking point. It's going to be the one without negative signs. So 4, comma 2. And I am going to plug that into my equation because I need to find b. So y equals mx plus b. Y equals m, I know, is 7 over 2 x plus b. And I am stuck because there's too many variables, and I'm only trying to find b. So I will temporarily put in for x this 4. Okay, and so I will plug this 4 in for x temporarily, and the 2 in for y, and let's see what we get. We get 2 equals 7 over 2 times 4 plus b. These fractions will go away. This 4 and the 2 will cross cancel. That'll become a 1 and a 2. So I get that 2 is equal to 7 times 2, which is 14, plus b. To get b by itself, I will subtract 14 from both sides. And I get 2 minus 14 is negative 12, and that's going to equal b. So now I will just plug in y equals mx plus b. I will plug in for my m and my b and leave x and y as x and y. So m was what? It was 7 over 2. So y equals 7 over 2. X, not plus, because b is negative. So 7 over 2x minus 12. We are done. End of video. Good luck, everyone, tomorrow.